Hi everyone, welcome to my YouTube channel. This is the video for last moment preparation or revision for first module. So spiral model, first you have to draw the diagram. This is the diagram: communication, planning, modeling, construction and deployment. For your just for understanding, I have written in the short form, and it was proposed by Barre Bohem. It is an iterative approach of prototype model plus structured and systematic waterfall model. So spiral is combination of this both. There are while creating a project, multiple new versions will come. Each new one is completed version of previous one. You have to keep this in mind. So it moves in clockwise direction. There are two major features for this. One is cyclic approach. This is iterative through repeating loops. And anchor points. Anchor points are nothing but the points which are the arrow marks here. So it is feasible and it ensures that the system is feasible and satisfactory system solution. The one main thing you have to keep in mind about spiral model is it is risk assessed. In each stage, when it iterates, the risk is also involved in that. Suppose if you are going with a food delivery app, if you are constructing the web page, what are the risks involved in that? It specifies that. And while going through this model, the first loop will always be the prototype, and the next second loop, third loop will be more completed or sophisticated softwares. Next we have unique nature of web apps. So for this we have this short form, that is Chandu SP, or you can keep it in mind as Chandu SP. First is C means concurrency. This C means content sensitivity, continuous evaluation, and this is I availability. N is nothing but network intensiveness. D is data driven nature. U is unpredictable model, unpredictable load, and S is security challenges. P is performance requirement. So Chandus, these are the unique nature of web apps. For new software challenges and myths, we have open world computing, net sourcing, and open source. For software myths, there are three types of myths, that is management myth and customer myth, practitioner myth, that is developer myth. Just keep the myths in mind so that you will know the reality. We have standard book, that is enough for building software. Myth 2, if project is late, adding more programmers to code will work. Myth 3 is that if we outsource the project, our project is done. Next we have customer myth. In customer myth we have two myths: a general statement of objective is enough, details can be filled later. And in myth 2 we have requirement can change anytime easily because software is feasible. In practitioner myth we have once the program is done, our job is done. Next in myth 2 we have only working code or only working program will matter. And myth 3, quality can be checked only after coding. These are the realities that I have given. You can go through that. So the next question is waterfall model and incremental model. You have to compulsorily draw the diagram if they ask waterfall and incremental model. In waterfall model, what you have to write is, you have to give explanation of all these 5 steps, that is communication, planning, modeling, construction and deployment. Here also you can give. In waterfall model, what you can write is, after each phase is completed, it will go to next phase and it cannot go back to previous phase. Okay, you can write this point, and it is a linear process or sequential process. You can write that. In incremental model, you have to draw this diagram. With each increment there will be new prototype or new model. You can write that. And it is linear plus parallel process. Linear plus parallel. In waterfall model, requirement should be specified earlier and final we will get the product. In incremental model, the thing is requirements can keep on changing, and in this we will get one final product, and here final products can change. This is suitable for small subtle projects, and this is for large risky projects. And in this, user involvement will be just once. They cannot keep on interrupting, and this user involvement will be more frequent. So the question is asked for software engineering practices. You have to write this four headings, that is understanding the problem, plan a solution, carry out the solution, examine result for accuracy. So in the steps you have to write further questions, that is, in understand the problem, who are the stakeholders, what are the unknowns, what functions and features are required to solve the problem, is it possible to create a smaller problems that is easier to understand. And in plan a solution, you have to think that, have you seen a similar problem before, is there existing software that implements these features, has similar problems been solved, can design models be created. Okay, carry out the solution. In carry out the solution, you have to implement the plan you have planned before. So in carry out the solution, does solution conform to plan? Does your solution matching the plan's requirement or project's requirement? Is source code trackable to design model? Have design and code review. And examine result, is it possible to test each component part of solution? So you have to check that, is it possible to examine each component, that is every stage of the design, and does the solution meet required requirement, that is your solution meeting the given requirement by the customer. So when they ask 5 generic process, you have to explain CPMCD, that is communication, planning, modeling, construction, and deployment. These 5 you have to explain. Communication is nothing but before any technical work can commence, it is critically important to communicate and collaborate with customers. That is, ನೀವು ಏನಾದರೂ ಸಾಫ್ಟ್ವೇರ್ ನಿಮ್ಗೆ ಏನಾದರೂ ಸಾಫ್ಟ್ವೇರ್ ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಕಮ್ಯುನಿಕೇಟ್ ವಿತ್ customer. Okay. And next is planning. A software project is complicated journey, and planning activity creates a map that helps guide the team as it makes the journey. The map, called software project plan, defines the software engineering work by describing technical tasks, resources that are required, the risks that are likely, and modeling creation of models to help developer and customer understand the requirement on software design. Construction, this activity combines code generation and testing to uncover errors in code. Deployment is nothing but the software is delivered to customer who evaluates the delivered product and provide feedback based on evaluation. So there was one more question where they asked demonstrate the examples for waterfall model and spiral model. For waterfall model, you can give library management system, that is communication, planning, modeling, construction, deployment. It should include all 5. For library management, first is communication, collect requirement; planning, estimate cost, time and resources; and modeling, design database, UI design; construction, code and testing modules. In deployment, you will have install in library and maintain. For spiral model, you have to write risk in each step in this. So in cycle 1, planning of this is online food delivery app. So in cycle 1, you have identify core needs, and risk analysis, risk of wrong order or poor UX. So you can write whatever you want. Just take these 4 points in mind: planning, risk analysis, engineering, evaluation, PREE. Okay. Planning, identify the core needs; risk analysis, risk of wrong orders or poor UX. So first the risk will be known. What if there are wrong orders or poor web interface, like that. Evaluation, user test basic ordering process. So in cycle 2, add online payment and delivery tracking, that is payment security and server reliability. Risk is that there will be security breaches. Engineering, implement payment gateway plus GPS tracking. We all know payment gateway and GPS tracking. And evaluation, user test ordering with payment and live tracking. Okay. Cycle 3, add advanced features. So cycle by cycle, you are improving the model. Add advanced features, risk analysis, fraud risk and handling, peak load or scalability. Deploy and integrate new modules. Evaluation, feedback from user, then refine. So next we have David Hooker 7 principle. First one is reason it all exists. Second one is KISS, keep it simple stupid. Third one is maintain vision. What you produce, others will consume. Be open to future. Plan ahead for reuse. Think. So you just keep all these things in mind so that you can fill in the content. So reason it all exists means software exists because it can give some value to the software or customer. Okay. Next, KISS, keep it simple. Keep it simple in the sense your software has to be simple but not simpler. That comes in this. Maintain the vision. You have to maintain the vision. Without vision, a software project cannot succeed. What you produce, others will consume. What you produce, others will consume, which means if you are a developer and if you are producing something, other has to understand that. It shouldn't be like that only you are understandable or only you can understand the software system which you have built. Be open to future. You have to see that what are the future scope of the software also. That means a software should be usable in future too. Next, plan ahead for reuse. The source code should be reused. It shouldn't be like once the code is used and it is thrown or it is not again, we cannot use that. Next is think. Before building anything, you have to think. So clear thoughts will make you build more valuable softwares. So that is the meaning of that. You can just keep this in mind and you can write in your own words. So that's it. These were the most asked questions or repeated questions. Thank you. Like, share and subscribe to my channel.